slicer settings and everything's assuming that there is going to be this tiny little bit of play, because they work it all out so that your prints look nice at the end of the day, right? That's what they've done. They've made the printer so that it works, so that your prints look nice, and generally speaking, it's told what to do, what it's told to do, and it does it, and then the prints also look nice, and they get it all calibrated. But that was back in the day a little bit longer ago when they didn't have dual drive extruders. And there was an amount of slippage that was somewhere accounted for magically in their equations. And I reckon that that's not quite right for the dual drive one. So I find I need to de-stepify my E-steps a bit to make it so that when I print a solid block of plastic, it doesn't over-extrude. That's what I aim for. I can print a solid block, taking into consideration that you've got to have a perfect first layer if you're doing that. If you try and, or put it on a raft, because if you judge a solid piece, whether it's over-extruding or not, by its appearance, and don't take into consideration if your first layer was too close, the entire print all the way up is going to be struggling and bulldozing plastic around the place. Because the excess from that first layer, like if you say you've got your nozzle, 0.4 millimeters, or you've told it that it's 0.4 millimeters above the bed, right? So you print your first layer at 0.4 millimeters. If your nozzle's actually 0.2 millimeters from the bed, then you've got this 0.2 millimeter slab of plastic, the entire shape of your model, getting bulldozed around on top of your model. So I often see people tell people to calibrate their E-steps when they're having first layer issues. And I want to slap the people commenting on the E-steps when someone's having first layer issues. Because there's no way you can know by looking at someone's print whether or not their E-steps are correct or whether their flow rate's correct, because you don't know how far the nozzle was from the bed. So the same amount of plastic is going to come out regardless of what the actual distance is. So as funny as it sounds, it nearly is always a case of leveling the bed and get it actually level, and then get it the right distance from the bed. If you're printing a solid part with no infill, it's going to look ugly all the way up. If you're printing a part with infill, which most people do most of the time, it'll have a slightly ugly bottom internal finish, and maybe the bottom couple of layers will be a little bit elephant-footed. And the rest of the print is immaculate, because as soon as it gets into the infill, all that excess has got somewhere to hide now. It's no longer bulldozing this plastic around. It's this solid slab of plastic all around the place. So I sort of want to slap people when they comment on E-steps when someone's having the first layers not sticking or something. It's like, woo up, get them printing, find out whether E-steps are no good when they're printing in the meat of the print, Like, I should move my camera.
Yeah, do that.
So it's like right on the side of my head.
I actually read an article the other day, and it was literally talking about reasons why not to calibrate your E-steps.
Yeah, the manufacturer.
Well, you just dropped.
Me?
You ran out of internet for a moment.
Me?
Yeah, you're back.
Oh,
you're back.
It was. I don't know what happened. I'm back. Because Cathy disappeared at the same time as you said, you dropped. I thought
no, she literally walked away.
Okay, I thought we might have had to call the ambulance. She said she dropped. So where was I?
E-steps, calibration.
Yeah, reasons not to. Oh, yeah. I reckon there's heaps of reasons not to mess with them.
Well, each filament has a different property.
Exactly.
So there was a part of the article was literally, well, hang on, you're not going to calibrate your E-steps for every filament you have.
Exactly.
Find out what the behavior of the filament is and tweak that in your slicer.
Exactly.
Plus or minus extrusion. Exactly.
For a reason.
Yep.
You've got a flow rate on your printer for a reason. There's reasons that you've got those easy to adjust things. And like, I'm not someone that knew anything about programming when I got into this. And for me, when someone said calibrate your E-steps, I was like, do you what? And so I kind of was very timid about doing it, and found that there's flow rate to adjust all that stuff with, and it works perfectly well, and there's really no need to. And I found for all the stock printers I've had, the Creality brands of printers, the Formbot printers, the E-steps that it was at, works. And I've never really had to do anything much more than plus or minus a few steps on the flow rate, like, you know, maybe drop it down to 98% or bring it up to 103% or something like that, to fine tune it to make it so that my prints look good.
Yep.
You know, so I kind of really look at the print itself, and there's so many other things that cause what look like over or under extrusion. Overhangs cause what looks like over extrusion. If you look on the frog, parts of this that are the ugliest, I'm not going to get too much into the details.
Right.
Lighting's gone terrible now. Yeah, so the ugly bits are the bits where the extreme overhangs are. Whether it's an inner overhang or an outer overhang, it makes a big difference. And if you've with infill, if you've got parts of the thing that go steeply inwards towards the center of the print, and you don't have enough infill to support them, but it's not properly bridging straight across, and it's kind of doing like a, you know, like the top of one of my skulls is a good example. It kind of wants to curl up, and that makes it pushing on the nozzle because it's curling upwards and it's fighting the nozzle a little bit. And so edges of bits where that's happening will kind of look a bit ugly. And so sometimes you get what looks like over extrusion on parts where there's extreme inner hangs, not overhangs, if that makes sense, if there's such thing as an inner hang. So, you know, when you look at a part, quite often you see when one element of a print finishes and another element of the print changes. Like you might see a color change in the filament when the tip of another model finishes. Like if you're printing these two at the same time on the bed and this one finishes, you might see the neck of the giraffe change color, and all of a sudden all the details on the back of the neck start looking crap. And that'll be because this element's finished now and the printhead's activity is now completely different than it was before.
Yeah.
Before it was going back and forth and there was time for this to cool and da 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 da, and then you know, there's a reason that in your slicer settings, in your cooling settings, that there's option of minimum layer time, and that'll slow down the print to make sure that there's bits have got enough cooling. And there's a lift head option to lift it up and bring it away if you don't want the radiant heat of the hot end being in the one spot for too long. So it's funny. There's a balance of the fans needed to be there for a certain amount of time to cool the molten plastic down, but then the radiant heat from the hot end starts to soften part in other parts. So it's like, you know, you do have to sometimes move it away. So your little things like that can often trick people into thinking, oh, my E-steps are out, or I need to calibrate my printer. And what it might be is you need to change something in your slicer settings so that it doesn't slow down so much and over melt the plastic, or it doesn't, you know, things like turning off combing because the nozzle's oozing out plastic while it's combing, and then it starts with a dry start. So, you know, if you're seeing dry starts on your prints, quite often you need to add a little bit of retraction prime extra amount back into your nozzle at the start of the line after a retraction. So in your materials set, actually they've moved retraction settings in Cura now into travel, which is much more sensible. And there you can find retraction prime extra amount and put a little bit of an extra squirt of plastic at the start when you've lost some in a travel. So quite often what looks like an under extrusion is actually just a stringing issue that you can't see because you're combing. Or even if you might see stringing and you go, well, that's just stringing, but where did that plastic come from? Where was it supposed to be? So, you know, yeah, quite often it's not E-steps at all. And I think that a newbie that's just gotten into 3D printing because they're interested in some creative pursuit and they bought a printer to pursue that with, or they've got a purpose that they need, you know, they're not into it for a hobby of learning how to, you know, pull printers apart. They're getting into it for wanting to just print a thing. I don't think they should be told to change their E-steps. I think they should be told to change the flow rate until they're happy in their slicer and be happy with that. But since playing with E-steps myself and getting the hang of that, it's not that scary. And the advantages are that, you know, you can set it so that in your slicer preview, you're not seeing the effects of the flow rate changes. So if you go into Cura and set it to 50% flow and then look at your preview, you'll see the flow rates reduced in your slicer preview.
Mm-hmm.
That in itself is a bit distracting. If, you know, that you'd probably prefer to have it so that, you know, Cura does say 100%. ultimately, but I don't think it matters enough to tell a newbie to go and play with their printers, build in sort of software that's, what their printer runs on. But there's a lot of people that are really good at that stuff and that have taught me a lot, and I'm learning more and more about it. I want to learn more because my passion for printmaking and sculpture got me into 3D printing, and the technology is what it is. You need to learn how to use it to its maximum advantage. So, there's you kind of, it's part and parcel of what it is. But not everyone's ready for that when they've first bought the thing. And I reckon the most important thing is to just get a successful printout and smile. I think that's you've got your printer, make it work. Don't go pulling it apart and putting a new hot end on the thing and putting an automatic bed leveler on it and this and that and the other thing. Just learn how to use the printer as it comes, unless it's a real dud. But I don't know, the Ender 3s all worked perfectly out of the box for me. The only thing I've done with the Ender 3 style hot end on a lot of these is put the Fang duct on.
Yep.
Which is more or less stock parts, except for that fan's been swapped over for a different one. And everyone probably knows Luke Hatfield, the guy that did the mod inside the throat of the hot end. Jim from Edge of Tech did a series of videos showing Luke Hatfield's steps on the Ender 3. If you're in the Ender 3 group, you'd know who he is anyway. But yeah, so Jim's video series talk about this hot end mod where you basically cut your Teflon tube off and shove it into your hot end again on the Creality hot ends, and then put this little 3D printed washer in behind it, and then screw that metal nut thing back down and pop your tube back into the back of that. And that way your Teflon tube can't slide up and down if that little Teflon coupler wiggles.
Yeah.
So that's the only thing I've really done on that end of it. And then I have put a 3D printed extruder on there because eventually the extruder arms wore out and broke, and I found 3D printable ones and printed them, and they broke, and I improved it in Mesh Mixer, and then they broke. And
cool. All right, we need to do an intro, I believe.
Oh yeah, cool.
Yeah, and this one's actually pretty important or big or
topical.
However you want to do it. Yeah, topical. So as you guys know, we try to give a break from PPE gear and everything else, and the ones who really need are the ones who've been very involved in this. And our next guest has been very involved. His name is Erik Cederberg, and I probably butchered his name. If I did, welcome to the club. But he actually designed one of the face shields that has been used the world over. And yep, exactly. That's his model right there. And so
bring that back up again, sorry. JT. Oh yeah, yep, sweet.
So we're gonna bring him in and actually talk about whatever he wants to talk about, because if anyone needs a break, it's this guy here. All right. So we're gonna bring him in right now and give him a minute to connect and everything else.
I'm going to find my mouse so I can mute my mic so I can listen instead of talk for a change.
Erik, give us 1 second. Your audio is connecting and you are on, sir. Can you hear us?
Let's see. I can absolutely hear you.
Yes, we can hear you.
Great.
Hey.
How are you doing,
if
sir?
I can get the audio from, let's see, like this. So no echo now. So great.
Can you hear us?
Good morning or good evening. Yeah, absolutely.
It depends which time zone you're talking to.
Yeah. I know.
But I think you kind of got it. Very early morning or in the evening time in Australia.
Yeah. So JT has the evening and I get the morning. So yeah.
So it's quarter past 6 p.m. So 18:16. About to be dinner time.
10 in the morning. So just after breakfast.
Yeah. It's 4:16 in the morning over here.
Oh.
So,
yeah, you've been going for quite some hours now.
Just a wee bit.
Mm-hmm.
I've been awake for 25 hours and 16 minutes, but who's counting?
Nice.
And I've been on since 18 hours. Yay!
Yeah,
Awesome.
but at least you got some time off when Samantha came in and took it and so on.
Oh yeah, and I was trying to relax and everything else, and I'm like, all right, I'll try to take a nap, but I didn't want to like oversleep, and so I just I unplugged the headphones. It was on the speakers, and I just turned up really loud. I started to doze off. I'm like, okay, this is good. And then Matt Stoltz's Alexa unit went off, and I'm like, what the hell? And I jumped up and everything else. I don't know what the hell. Because all of a sudden you just hear a voice talking. I'm like, what the hell's going on? So yeah, no, it was good. I got some time off and everything, and still going strong. Got about 5 hours and 45 minutes left of this grand experiment. So how are you doing over there?
Oh yes, I'm doing pretty okay today actually. Not I've managed now to get off from the whole PPE thing is more or less for about 3 days.
Good.
I've basically before that I spent more or less every awake hour for a month. With like I think I had like 2 evenings off in total for a month.
Wow.
And those evenings were like 4-hour evenings. So yeah.
Who needs
Wow.
sleep? It's overrated.
Yeah. Why do you need it? I haven't get it. So.
Oh, I can give you about 10 good reasons right now.
Yeah. So can I.
So you've had the weekend off, yeah?
Yeah, I've had weekend and actually since first days somewhere.
So what was like that one thing that you were looking forward to the most? You know, just having this time off. What was the first thing? Like, I'm doing this.
Sleep.
I was gonna say besides.
Of course. But I went out and hiked for about 15 kilometers with a friend. In Thursday evening, was quite nice to get outdoors and get out of my apartment. I've more or less been spending all the time inside for a month then, of course, since I was doing the things.
Yep.
So it was quite nice. And spending some time sitting on my balcony and reading a little bit and so on. So.
Good.
But you've had pretty lax restrictions, no?
Oh yeah, we have. We're probably being made fun of in half the world media, so because of that.
Yep.
Oh, mate, you've redeemed your country with your design.
Mm-hmm.
Well,
no, but
unless...
yeah.
Go ahead.
No, but I would say that the interesting thing with how the media reports about the very lax restrictions have been is that there's also quite a cultural difference that they usually don't manage to convey. Where in Sweden a recommendation from the government is almost seen as a rule.
Okay.
And people are very rule abiding in the traditional Swedish mentality. So I know there have been some studies that have shown that usually when the Swedish government makes a recommendation, it has about the same effect as a rule has in the south of Europe.
Okay.
That's interesting. People probably have a bit more respect for the authorities when they're not actually being authoritarian as well. So they tend to want to just do what's morally right, not what they feel rebelled to do. Is in compelled but rebelled.
Yeah.
Yeah.
Yeah, but now we shouldn't be talking about that stuff. That's not the fun part of today.
Oh no,
Sure.
I kind of wanted to talk to you about your design for a moment because I did a remix of your design, which I just dropped one.
Yeah, sure.
I made a third arm for it.
Mm-hmm.
And I think that's pretty much all I did. And sort of.
Oh yeah, you also
it forwards. That's right. I pushed it forwards.
You extended
and
the
made
font
a little bit at that part there taller.
The problem with that, of course, is it doesn't fit on a
no stacking
bed.
No
either.
stacking and
Yeah.
that's that's sort of I just built it for what I had, I guess. But
No,
it's a good design. And then I ended up getting an order for 200, but they had a specific design that they wanted, so I didn't end up using that anyway. So thanks, man. That's awesome.
Sure.
I'm really stoked to see that sort of take off for you. I think it was really cool.
Yeah, and I've been seeing so many remixes of different kinds by now, and people.
Oh, I bet.
You wouldn't believe how many emails I got like the first 3 weeks. This week has actually been a little bit calmer, but I probably had like 50 plus emails every day for 3 weeks in a row.
Yeah, well, that'll keep you awake.
It takes some time to answer. I've been pretty happy to have a workplace where I could focus on this.
Yep.
My boss have been asking, like, Erik, when are you going to be able to get back and work with regular stuff again?
So you work with printers and
Oh yes, I do.
Does that work? And cool for your day job, not your own business, or?
No, that's my day job. But cool. On the other hand, I'm one of those guys that doesn't know how to have a day job properly. I've been running my own business since a couple of years before.
Yeah, cool.
Like half my family is running their own businesses. So wherever I work, I probably work as if it were my own.
Yeah.
I have a very hard time separating that in a good way, but yeah. It's good and bad. I work at a company that I really like, and I have really good colleagues. And my boss is a friend of mine who we actually met about 8 years ago now when we started a makerspace in Stockholm together.
Yeah, cool.
So we were both co-founders of that makerspace, and then he came and asked me like 3 times, you want to come work for my new started 3D printing company? And I said, no, I got my own business for like 3 times. And a few, like 2 years later, okay, yeah, sure, I'll join.
I'd love to take a wage for what I do. It'd be great.
All right, Cathy, you off?
I'm just going to head off now. Thanks very much, Shane. It's a great
Anytime,
experience.
Cathy. It was great to see you. It was great to
Thanks
actually
very
be on
much.
with you.
Yeah, good night, Cathy. It's nice to meet you. I'll follow you on Twitter now that I'm a Twitterer.
Awesome.
Have you got a YouTube as well, or? Oh, you do.
Yeah,
I found your YouTube from Twitter or from somewhere. I found it. Yeah, that's right. I watched that.
Yeah. You and my 22 subscribers.
Cool.
Hey,
awesome.
still get
Thanks,
views.
guys.
Sweet.
All right, see ya. Bye.
Awesome.
Have a good
Yeah,
evening.
Cathy. I'm off too. Dinner
You're
time.
off too? Okay.
Dinner time.
I might come back later.
You might promise her a threat.
Yeah, either.
All right.
All right. See you, Erik.
I'll see you.
Sam,
See ya.
Shane.
See you, mate. Thanks for inviting me.
Okay.
Ciao.
Catch ya. Bye.
Later. Okay. So, let's see. Now, I can either probably ask you a question that's not related to what you're known for, but you probably got asked. I don't know if you got asked a lot. I mean, like, I don't know if you got interviewed a lot for what you did, but if you got...
I have got some interviews, absolutely. Okay. Then most of them weren't very 3D printing related. Let's say that.
Okay.
So they were like media that had like the idea of 3D printing in like this much.
Mm-hmm.
I think I had to edit the text from my local newspaper like 2 times because they wrote like, yeah, this was a. He made a guide for the printer how to make the part because like the reporter had no idea how a 3D printer actually worked.
Yeah.
It was like the replicator guess more or less.
I used to work for Prusa Research. I used to live in Prague a long time ago. So I remember one time it was in the Czech news and they were like the guys had to translate it for me. It was the funniest thing. They're like, you can make a bomb with a 3D printer. And like, it's so dangerous. You can do weapons and everything else. You know what the bomb was? Did you ever play Fallout?
Yeah.
You know the mini nuke?
Yeah.
That was the bomb.
Oh, it's a
And
bomb.
I'm just sitting there. I'm like, oh my god, this news story is a bomb. But it was just so funny. We're sitting there just howling, laughing at the whole thing. It's like you can make guns, and it's like that's a fake gun. That's from a video game. What
Yeah.
do you? It's like the whole the just like the whole to sensationalize it so much just to get views and everything else. I was just like, oh, you got to be kidding me.
And all that debate on and the media attention on like you can make a gun with a 3D printer.
Yeah, when I would do the show, I would do the make affairs for Prusa and everything else, and like that was like always a very common question. And me personally, I'm like, look, I'm not going to talk about it. I don't want to talk about it. I'm not informed well enough, to really sit there and say, oh yes, it's done completely safe and everything else. You should go ahead and do it. No, I'm not about to sit there and say that. And then like people would push it, and it's just like I would just end up walking away half the times. I mean, like the only time that I ever got really interesting, it was in New York City Maker Faire. It was two teenagers. They kept it up. I walked away, and they kept following me and like asking away, and it just thought it was weird. So I stopped and turned around. There was a policeman over there, and I'm like, look, guys, if you want to, we can just go right over to the cop. You can ask me whatever you want to in front of the policeman. And they just turned around and walked away and everything else. I'm like, all right, that's dumb.
Yeah.
Some people, they just don't get it.
No, yeah. No, I actually had a, like when that debate was like the first time it was really big around, when the Liberator was released.
Yep.
Yeah. I actually got in this on Swedish national TV talking about it.
Really?
It was one of the more interesting phone calls I had in my life. I was driving to work. I wasn't working with 3D printing at the time, but I was running the makerspace. And I was riding my car into work and got a phone call from a number I didn't recognize. So I was like, okay, yeah, let's answer that. And I was like, hi, my name is Johanna or something like that.
Yep.
I'm a researcher for the Crime of the Week show. I really want to talk to you.
Okay.
And you're like, what is this about?
First question's out of my mouth, like, what did I do? What did I do? What did I do?
That was the first thing in my mind too. It was like, I don't know what this is about.
I didn't do it. You didn't. No one saw me do it. There's no proof. Go ahead.
I think in Australia, if you're if your kid draws a picture of a gun on a napkin and you own a 3D printer, I think that you can go to jail.
You own a drawing.
Don't let your kids draw guns on napkins if you live in Australia and own a 3D printer, or you'll be in jail. That's pretty, or at least New South Wales anyway. No, it's literally an offence to have a blueprint for one, and what they mean by that is an STL. They call it the blueprint, which is just funny. But you totally can't. And it's the way they're written. What I've read of their legislation, I'm scared to have like a Warhammer character with like a bolt pistol in his hand. It's like it's sort of silly. But it's understandable. They don't want people walking around shooting people. But I don't know.
Oh, of course.
It's a what's the word for it? It's a very interesting can of worms that they've opened by trying to legislate around it because, and then people have had lathes for how long?
Forever.
Isn't that
more or less
how like there's a lot of people making their own dangerous things.
And the hardware stores.
Yeah, you go to Bunnings and you can hire a ramset nail gun with a 22 bullet.
Yep.
Driving a nail out of it.
Yep.
It's.
No, actually, when that TV show contacted me, they first were like, "Yeah, can we print one of these Liberators on the show?" And I was like, "That's probably not a good idea, because that's going to probably be classified as gun manufacturing, which is illegal in Sweden. You probably don't want to do that on national television." And they were like, "Oh yeah, you're right. That's probably not a good idea. Can we print something else that looks like a gun?" Sure.
Non-working, non-functional.
Yeah. We ended up printing a Walter PPK model from Thingiverse. Just a really toy gun, but looked like a gun. So.
Yeah, so that's illegal in Australia. New South Wales, if
Oh.
you have a 3D printed thing that looks like a gun, I think even if you make one out of wood and paint it silver, I think that's enough to get locked away. As long as you, I don't know, maybe if you painted a red end on it, maybe you get away with it. But I don't know. I think the new legislation opens up a big can of worms as to what you can and can't do, because you know, and I've just gone. I'm not touching any of that with a barge pole.
No,
You know,
shouldn't.
it's just, you know, it's just too. I've got a legitimate business. I don't want to, you know, have anything to do with anything that's going to be a risk. So, like I said, you know,
you shouldn't.
If I've got a little tiny miniature space marine and he's got a bolt gun, I'm worried. If it looks too much like an actual bolt gun's fine. It looks ridiculously not like a real gun. But if you know, if someone had something that looked more like it, it's like, well, technically that's a model of the gun. You know, like especially if it's not stuck in his hand. If it's like, you know, separate to it, because I mean, all you got to do is scale it up. But I don't know whether the laws are like money in Australia, like counterfeit money. If you have a print of something that looks like our money, you can do it if it's like really, really big or really, really small, but you can't do it if it's anything close to the actual size. So you could print, I think anyway, you can print like $100 note that's this big and it's fine. But but the funny thing is that the legislation goes down to the digital level as well. And if the digital file is at the right scale, it's illegal. If the digital file is scaled up or scaled down, it's legal. And it's like, I think that's pretty much how it is. Like, I'm not a lawyer, so don't get me, you know, but I think that's how it is with money piracy. So I don't know how it is with illegal firearm, you know, plans. But yeah, I wouldn't trust one anyway. Surely they've got to be blowing up in your face.
There is a surprisingly large community around that if you look online.
Yeah, okay, yeah.
And surprisingly many has got stuff to work, but yeah, no, that's a whole can of worms.
Yeah, let's not go there because I don't feel like getting. I'm in the U.S. I'm the one who's going to get, you know, on the front door. So
now we can segue into something else. So I have a 3D printed knife here, for example, or
nice.
just a knife handle, but still.
Nice. I'm just waiting for this one. I know I'm going to get a phone call.
Carbon fiber nylon.
Oh, really nice.
Yeah.
I'm probably going to get in trouble for this, but I'm going to make a handle for this one as well. A guy wanted a handle for that, and I don't know. It's probably. I don't think it's that illegal. I'm sure you're allowed to have a knife, but yeah, that needs a handle on it. He wants a skull handle for that, so that's a pretty cool project. One day when I get to that.
So, Eric, I got a question for you. Now, after all this is all taken care of, right? There's a vaccine or whatever, and it's not. It's well under control, right? Is there anything that you know that you're gonna do, like, you know, reward yourself or go a different, you know, if like, are you gonna take a vacation somewhere? Are you gonna study a different field, or, you know, I mean, like, what are you gonna do? What do you want to do?
Definitely going to take some kind of vacation after this is over. Like, more or less all of the things I was going to do this summer is cancelled now. So yeah. No, I'm a since a lot of years back, I'm an active scout leader. So I was going to 2 international camps this summer.
Nice.
As a leader. Those are both cancelled now, or well, one of them is postponed until next year, and one of them is cancelled. But I'm still planning on going out sailing this summer if allowed, which hopefully wouldn't be a problem. Yeah. No, I don't have that many plans, to be honest, to what to do after this, because who has time to think about that? More or less. I've been doing so many projects now with like corona related stuff, so it's crazy. You've all seen the face shields. but let's see where I got those. No, I don't even see them right now. But I've been doing stuff for like this is high flow oxygen devices. We're doing a project on splitting those. shfno.org. So we're doing working with a medical team with doctors and stuff. On doing systems to split flow from high flow nasal cannula oxygenation devices. Yeah, that's a mouthful. And like doubling the capacity of those. This is not the ventilators, by the way, just because everyone get that mixed up. These are actually relatively suitable for sharing. So I've been working on that for like 3 weeks. I've been working on, let's see.
So was that an adapter for something like a CPAP machine that's just
it's a HFNO is like a constant flow CPAP, but where you only have a nasal cannula into your nose, so you don't have a mask.
Yeah.
So you're basically replacing your the air you breathe in with a higher content of oxygen, and it's humidified.
Yeah, right. Yeah.
So it blows like 30 liters per minute of oxygenated air, and that is like 100% humidity into your nose.
Yeah, right. Yeah. Yeah, friends of mine have worked on a ventilator system and also some adaptions for CPAP. The Spark Vent 2, they've called it. If anyone wanted to check that out, it's a pretty cool project. They made a proper full-blown ventilator system that's totally untested, and they don't want to have anyone have to rely on, but they've got a functioning system.
Yeah. No, we actually. The interesting thing with the HFNO devices is that at least now the most tests and studies show that if you can put a patient on high flow oxygenation in nasal cannula, you can in like 80% of the cases avoid having to put them on a ventilator.
Right.
And the HFNO treatment is extremely much safer and does not cause as much invasive damage to the patient.
Yeah,
so
right.
you have much better chance of recovery if you can avoid the ventilator. We're also working on a solution to set some CPAP machines to be able to work in this mode because they have a high flow mode, and then you need to add external oxygen. So we have the splitter and then adapters with oxygen nipples on them, so you can actually connect oxygen supply into the CPAP like in the flow to be able to do this.
Yeah, right. Yep. That must be something to do with what this adapter that I printed from a friend.
Yeah, probably.
And there's another little part that's like that I've printed for them. So I'm not exactly sure how that works, but that's a cool one.
No, I'm doing CAD and technical things, and I leave all the medical things to the medical professionals. And since I've been working with the team, the team leader is he's actually like the head physician for a COVID-19 ward.
Yes, right. Yeah, great.
So like that's the right place to go to for it. I to be honest, I've had a little bit had a problem with people, like how people approached the whole problem, where like 100 different teams of engineers thought that they would reinvent the ventilator, and everyone started working at that without really like consulting any medical people.
Yeah, well, my friend's the guy Hamish that kind of was driving the project. I guess he's an anaesthetist, so he's on the front line, and you know they've he's an engineer of sorts. What was it? Biomedical engineer.
Yep.
And then Jamie's a mechanical engineer. And I actually introduced them. I really had not much to do with anything. All I did was sort of just knew a few people and introduced them, and they've done this thing. But so you know, I guess it's interesting because not knowing how widespread it's going to be and how many people are going to need it, we don't know what materials we're going to run out of. So I guess lots of different approaches is good.
Oh yeah,
But at the end of
sure.
the day, I found it quite interesting the way that the community kind of self-organized, and it makes me wonder about the next thing. What is the best approach for when that sort of thing happens? How do we mobilize a worldwide network of designers to tackle problems?
Yeah, and it's interesting in some how to see how it organized. But it's also a bit frustrating when a lot of these ventilators then were these like bag squeezers robots, and like there were probably like 50 projects in a week that started doing like exactly the same thing.
Yeah.
And as soon as you started talking to actual medical professionals, everyone says, no, that's not going to be useful in any way of treating COVID-19 because you're going to ruin people's lungs with it. Because you don't have any pressure feedback, for example. So you're actually going to blow the lungs apart.
They had a safety feature for that.
Yeah.
I don't know enough about it to comment.
No.
So it would be a case of looking up their particular design and
yeah.
Not now obviously, but I just thought I'd put them on the radar because they did.
Absolutely.
They did do a lot of research for their work, and I think they're appropriately qualified.
And it also sounds like they had a better starting point than most had, because most people said most teams seem to just be engineers that were bored and said like, yeah, let's do this. We're just gonna force some air in and out. It can't be that hard.
Yeah. And look, it's great to see everyone trying. Like I modified your face shield, which is perfectly functional as it was, obviously, because thousands of them are being printed. But then I think every man and his dog fancies himself as a designer and wants to jump in and do something. Everyone wants to do something, and I think at some point everybody running around in circles trying to do something is what you're talking about with the frustration.
Yeah. A lot of it, absolutely.
And tripping over each other, and and I ended up just finding somebody that was taking donations for masks and contacted them and said, I'll print you some masks. Let me know how many you want. And they sent a purchase order out for 200 and I printed 200. And then they've since shut people down from printing anymore because the medical need has ceased in Australia. We don't need any more at the moment. We're on top of it, apparently. I think they must have got a shipping container full of regular masks or something. I don't know. But so at the moment, they're good for masks. 3D1 in Queensland that I printed mine for have enough. And so, and it's great. I mean, if we met a need, then that's awesome. And so you guys are still printing them flat out over there, or?
No, I would say that we have basically, I will not say that we have stopped printing face shields because we haven't. There's still quite some volunteers and makers doing it around Sweden, but we definitely stepped down a lot. This printing of face shields, it was always a gap filling measure. It's just something we do when there's a need because there's a gap in supplies, and it's not meant to replace the real face shields or real. Production has stepped up in Sweden now, so we have gotten multiple companies making face shields. For me, it's even more fun because we have 3 companies right now. It's going to be about 5 next week, I think. That is actually injection molding, basically a derivative of my design straight up. So there's about today I think it's like 28,000 a day, something like that, made injection mold in Sweden. Next week is going to be closer to 50,000, I think.
I got a question for you. You said you used to work or run a makerspace, correct?
Oh, I'm actually still.
Okay.
I'm still active board member of the makerspace since 8 years.
Even better.
So yeah.
Now, some of the hospitals here in the States, they have their own little maker shops or spaces in there. It's primarily for whether it be for repairs or creating certain type of equipment or anything else. Now, the hospitals over there, do they have a similar type of setup there, or?
Some.
Mhm.
I would say there's not a lot of them, but there are a few. So actually, the people I've been working with this HFNO splitter project, half the team is from the 3D Print Center at the largest hospital in the south of Sweden. And I think there are like 3 or 4 more hospitals that actually got that.
Mhm.
But it has been hard getting 3D technology into the hospitals. Then of course some hospitals has the more old-fashioned workshops, like with just the technician and a pillar drill or something like that. So it all varies a lot on what hospital you're looking at and so on.
Okay. Besides the medical area, is there another field that you would like to see 3D printing become more involved in?
All the fields.
Well, I mean, all right, let me phrase that. Would you have a certain passion for one, whether it be automotive, aviation, or anything?
I would say automotive and aviation, they already know.
Mm-hmm.
They're already into 3D printing quite a lot. I don't think that's the businesses that needs to be driving innovation into right now. They already bought the whole 3D printing thing.
Mm-hmm.
There's a lot of interesting areas where you can bring 3D printing into.
Yep.
I do think that this crisis actually will turn out in more companies getting 3D printing in, because it's a cost saving measure in many cases. But the whole jigs and fixtures for production lines has been the large thing the last 2 years, and it's going to continue because it's such a huge cost savings there, and it makes so much sense. So
okay.
I've been to countless companies and looking at that. And then I'm not even that much out there. That's for the salespeople. I'm not sales.
I can't stand salesmen.
No. I'd like to see it 3D printing going to consumer electronics a bit for small runs, and to stop how there's always a new model of something. Imagine all the tooling that goes into those new models. If some of the components could be 3D, even if it's just a chassis that you don't see, or
yeah, but actually, quite a nice example is a friend of mine. He's working at a company that makes they make sensors and alarm panels and stuff for control of lighting in commercial environments, and they do also like alarms and stuff like that. They sell products to electricians that put them up in places.
Yeah, cool.
So like they do passive IR sensors and stuff like that.
Yeah, is that dangerous voltage behind those, or is it just your low voltage?
Yeah. No, there's absolutely full mains voltage and a lot of stuff.
Yeah, cool.
But they actually started printing quite a lot of components. They started out with just making all the test fixtures and test jigs for the products printed. They have really nice printed test jigs nowadays, actually. I think I had one.
Jigs for testing printed parts?
No, jigs for testing their electronics in production.
Ah, yeah, right. Yep.
So like all the pogo pins and test fixtures and so on. I can't seem to find that one. I thought I had one on my desk. No,
what's a pogo pin? Is that something that just pushes a button a million times to see if it breaks?
No, it's a spring-loaded pin that goes onto the PCB to actually measure voltage.
Ah, okay.
Yeah, to connect somewhere. But they started out doing just those test jigs with the 3D printer. But now they're actually starting to do low runs of some products in the printers.
Yeah.
So, for example, they do some custom panels for like alarm modules and stuff like that. And they actually printed those now. A long time they said like, no, it's not looking good enough. It doesn't work well enough, and so on.
Yeah. I think that's going to become less and less of a thing.
No, and they actually got them really nice looking now. They found a way of using a quite matte white PLA, and then used they also used some matte ASA for some other things, but they used a combination of a low setting on the Cura Fuzzy Skin. That
I
setting.
love fuzzy skin. Yeah.
And they actually managed to get a really nice texture surface that looks so professional.
Yeah.
So they're now doing like these really professional looking panels.
Nice, man. Nice.
And some of those panels are stuff like that. They make like 15 a year for a certain customer.
Yeah.
Which makes no sense to tool up for.
To tool up for, exactly. Yeah. No, that fuzzy skin, if you use right, like I've got some examples that I won't show it all off, but I've got some examples where I've really played with that, and you can get some really cool effects, especially with dual extruder when you put a transparent over the top of a clear. Like I did a Hulk, and he's got green underneath, and then transparent green over the top, and he looks all shiny and sweaty and wet. So like the inner wall is normal green, and then the outer wall is translucent green. The little things
nice
like I've done frogs where I've done fuzzy skin doing the same thing. I might as well get one. Yeah.
So I'm still trying to wake up.
Keep talking. Keep talking. I'll just silently show these
around
off.
and find stuff there.
I'm sorry?
No,
I'm just sitting there. It's like, all right, if I drink any more caffeine, there's no way I'm going to go to sleep when this is all done. I'm like, if I don't drink any more, if I don't have any more, I'm going to fall asleep in an hour. So it's going to be fun.
No, but you know that caffeine only has like a physiological, like it only works in a physiological way on you for like 30 minutes or something like that.
Yeah, but with the amount that I've already had,
everything else is psychological.
Yeah, up
which
here,
is bad enough. But
yeah, you don't want to. There's been doctors who tried to figure it out. Oh wow,
that's really nice looking.
Let me try to.
And the cool thing about this is I'll get the blowtorch and show you something awesome. Let me get him. I'll try not to cook him.
I'll get the blowtorch. That's a nice phrase. Oh, it's from thermochromic.
Yeah, the inner layer is, not the rest. So it's only the. I'm trying to cook him too much. But yeah, so that's probably still soaking in that heat, but you can see it's starting to lighten him off there, and so that's a bit of fun. And I didn't remember that this was a white one, but some of the ones with colors, you get the color change interacts completely differently, and you get some really insane blends. So you might mix like a fluoro yellow with a purple that changes to pink, and it just really does cool stuff. It goes from looking kind of looks green for some reason when it's purple, but then when it goes pink underneath, it kind of looks like an orange cooked prawn. So it's sort of like if you drop these little frogs that I made in warm water, and it looks like you're cooking them and they're going red.
Nice. Yeah, I just, when you showed off that thing, I just realized I had this one sitting on the bench behind me right now. I'm gonna finish this one as soon as I get some time. Also, this has been in a work in progress for like 2 years. Renee, who designed it, is still mocking me about not finishing it for so long time. I don't know if you know about this printer model.
I'm just trying to see it bigger. I can't. For some reason, my big head's all over the Zoom screen, and I can't see you. Do I double click you to?
How about now?
There we go. Yeah, cool. That's better because I was. Now all I can see on the YouTube is me staring at the screen really close. Cool. Yeah. Wow. That is an insanely industrial-looking printer.
Yeah, it's a dice. It's called. It was designed about 2 or 3 years ago by a guy called René. He's on Twitter too, René Jurak, but he's not very active. And he's a German engineer, and designed this insanely robust printer. If you're looking up dice on YouTube, you can see some places where he done like 8,000 millimeters squared in acceleration, I think. With almost no ringing.
Wow.
It's a micro Core XY.
Wow, that thing
it's
is solid.
It's super solid. It's 2 millimeter stainless steel and 4 millimeter aluminum plating with milled corners. Linear rails on all axes. It's Mizumi rails on this one, high quality ones. And it's a custom water-cooled print head with his logo engraved on the water cooling fronter. Radial fans with a custom fan shroud, but made out of like 0.5 millimeter bent stainless steel. It's a bed with a stainless steel flex plate. It's not on there right now. It's water cooled, both the print head and the drive board actually.
Wow.
I even made a. It's made to be used with a. I think it was some of the Aztec drive boards from the start, but I didn't get that one. So I'm actually mounting a duet into it. So a while back I milled this duet heatsink adapter. So this is milled aluminum that I sandblasted some parts of. So this actually goes underneath the duet board and firmly couples it right under the stepper drivers. Yeah, I have to let the pins go in there. Yeah, like that.
Because when you start moving the printhead at those speeds, you want to make sure that you're keeping those drivers cool, don't you?
Yeah, and I also don't want any noise from fans. So.
Yeah,
it's probably totally overkill to water cool the duet stepper drivers, but if I have a printer that is made to be water cooling drivers, why not?
It's actually, if you're going to put the thing in an enclosure, it's not overkill at all.
No, it's actually got this custom water cooling block at the side. This is just for cooling the drive board.
Wow.
Custom milled water cooling block with fins in there and small divots to create turbulence in the water and stuff like that.
Are these guys still making these?
No, he's not.
Oh man, what a bummer!
But it is open source. Actually, I bought the print head, I think, and the flex plate. I also bought the aluminum corners for it, but all the other parts I've actually got water jet cut from a local place there. So
yeah, cool. Okay, yeah.
It is an insanely expensive printer for the build volume because it has a insanely small build volume.
Yes.
I think it's like 75 by 90 by 85 millimeters, something like that.
Yeah, but by the sound of it, if you're going to print objects that fit on it, it's going to do it a hell of a lot quicker.
Oh yeah, and
at the same resolution
detailed.
Yeah, that's right.
Yeah.
You don't have to jack up your layer heights to speed things up.
No, it's probably one of the fastest small printers you can get, actually. Yeah, and of course on the back here, that's the water cooling pump up there. Nice. That's the Duet Wi-Fi antenna. There's the very much overkill power connector. I like good connectors, so well, it's a Nutric PowerCon. And there's the original Bontek BMG.
I like the way that's just mounted straight onto the frame with the motor on the inside. That's cool.
Yeah, no, it's actually really impressive. If you lift off this, the backside is exactly the thickness of an NEMA 17 motor.
Wow.
So the motors are almost clamped between the two aluminum plates.
Well, that's another way to heatsink it, isn't it? You could even put a bit of paste in there if you wanted.
No, so it's super tight, everything in here. And actually, one of the things that has been taking some time is figuring out how to route like water cooling hoses and stuff like that in a printer that is this tight.
Yeah,
and actually getting everything to flow right and so on.
yeah. You don't want any kinks or bends or anything.
No, and yeah, you see here, the water cooling hose goes in there and up there and up to the print head, and yeah, everything is really tight in this one.
A friend gave me an Ultimaker printer that was an old wooden one. It's actually up there hiding away, and it's got water-cooled hot ends all over it and bits and pieces. The board's not water-cooled, but the hot end is water-cooled, and yeah, it was super duper overkill, overdrive. Everything was beefed up on it, and I haven't done it justice and got it going yet. Really, it's just chilling out there. And I actually sacrilegiously harvested a big NEMA 17 off it for my CR10.
Oof. Yeah.
Sacrilege.
I can show you. Let's see. No, I've actually did a I'm modding a Ultimaker original for our makerspace. Let's see if I can share the screen. Yeah.
That's a taller one than the one I've got.
Yeah, there is no such thing as an Ultimaker original extended. I can just say that. We kind of did that ourselves.
That's awesome.
Since it's open source, why not just open it in Illustrator, stretch the DXFs a bit, add in a couple of more tabs, switch out the rods and the seed stepper, and make it an extended one. And that's also why Decide's got our Makerspace logo on it. Because we did Element Laser, so why not? And
that looks like nice filament. What on earth is that? Is that transparent or is that shiny?
Yeah, transparent orange color fab.
It's very shiny, nice looking. Yeah.
Yeah. No, it's actually really nice looking in real too. No, so and you see that the also the controller on the front there. It's an Ultimaker 2 controller and screen.
Yeah, cool.
So this one basically operates as an Ultimaker 2, but and the print head is also an Ultimaker 2 print head, and the feeder is a Bonta QR. So yeah, this is a really modded one. I think the funniest thing though was when we first put this one together, and engraved that Ultimaker Plus extended on it. I took a picture of it just when it was all put together. Then I sent that image to Sander van Gelen, who was he's still the Ultimaker community manager. And I just said, "Oh, thanks for the prototype. It's worked really well."
Oh, that's cheeky. That's fun.
Just to confuse him a bit. The 3D Workstan, which is the company I work for, we actually we are the Nordic and Baltic distributor of Ultimakers, so we know those guys pretty well.
Right. Cool. Yeah, I was wondering what the relationship was. You're lucky, man, actually working for a proper established business in 3D printing. It's so much cooler than trying to skull drag yourself into an existence.
Okay, I have to show you one more thing. So let's see.
Whoa, far out.
This is about 2 weeks ago at our makerspace. We did I should not say that we did because I wasn't really involved that much at all. But like just 2 days after I said I released the face shield things, a friend of mine from Makerspace he was contacting me and was like, "Yeah, dude, is this face shield thing really needed?" And I was like, "Yeah, there's a reason why I spent time on this." So you're like, "Yes, so it's a real need." Yes, it's a real need. Okay, don't you think we should arrange a print farm on the Makerspace? And I was like, I'm totally choked up with work, but if you want to do it, I'm super happy if you do. And so he basically managed to borrow. This is the event space of the co-working space, which is in the same building as we are.
Yeah, cool.
And he put out a text on our Facebook page and was like, "Yeah, we're gonna do a print farm to print stuff for the hospitals. if you want to lend us your 3D printer,
cool.
we're going to keep it running 24/7.
That's a much more efficient way of doing it than having everyone print them at home and then post them in individually, and you don't know how well sterilized they are. And
no, so we actually, so he started borrowing 3D printers from different places. It was companies, schools, individuals, everywhere. And in the end, it was like,
wow.
I think we had 55 printers running at most.
Wow.
So it was 55 printers doing 24/7 printing. Yeah.
Wow.
I think we had, at most we had an output of 2,500 of the face shield frames per day.
And I thought 200 was a few.
200 is a few. 2,500 is a lot.
Yes, that's right. Yeah,
it's quite crazy, to be honest. No, but we had 24/7 staffing of people. We crowdfunded the filament and everything. Managed also to get like donations for like 200 or 300 kilos of filament in total.
And what sort of print times did you get them down to?
We did run them a bit up. Yeah, we did run them a bit conservative because we were more concerned with like reliability than with actual like maximum per printer. So I think we ended up at about about the 40-minute mark for two, like 38 minutes or something like that.
Yeah, no, that's good. And that's with the Ultimakers, yeah.
Yeah.
And generally, and the other printers, various, you might have had not so
various, depending on what nozzle were on them and so on, what we could do with them, and what hot ends. But I would say under the hour for two on most every printer. Except the Ender Freeze with the 0.4 nozzles, they took longer.
I did 11 with my 0.4, pretty much stock Ender 3 in about 8 hours. But that was with stacking. Yeah.
I think this one is the speed record of I've had so far. It isn't very pretty, but it's decent.
Yeah, so it's functional for sure.
Yeah, and this is like 7 minutes, I think.
Nice, yeah, and looks very strong.
Oh yeah, it's super strong.
That's actually, I caught that photo as you were going through before, and that's the one that made me ask you what print time you got them down to, actually.
Yeah, no, I think the 7 minutes is like at least that's the fastest one I've been directly involved with. And 7 minutes is insanely fast.
Yeah, that's great.
That's with like I think a line width of like 1.33 millimeters, something like that.
Yeah.
Yeah.
And did you do much stacking? I just saw the photos of them stacked. Are they from you guys or from someone else?
I've done some stacking, but I've mostly done multi-extrusion stacking.
Yes, cool. Yeah.
So like these are dual extrusion stacking.
Yeah, brilliant. And were those ones a bit more solid? Like the flangey bit on the forehead was actually a full.
I've filled that one for them.
Weird.
I filled that one. No, the reason for the tray in the front is purely material saving. So if it doesn't
and
fit
it's time, heaps of time saving for sure.
Yeah, exactly. Some people don't seem to understand that, and a lot of the remixes just removed that bottom part because they were like, that bottom part is just unnecessary. We're not going to do that.
On one of my remixes, that bit, when I extended it, that bit kind of disappeared because it was never there. And I think on another version, I don't know if I can spot it. Oh, yeah, here we go. I put it back. But it was just easier in this one to do it solid. And I think one of my mixes floating around somewhere is now then reduced back down to the height the original one was. And too many iterations, man. Like, and again, with every man and his dog wanting to have a go, eventually I just settled on who needed something printed, What do they want? I'll print that. Here we go.
Yeah,
And
and
got it out to them,
that's
you
a
know.
really good way of doing it.
Yeah, but in the meantime, I thought, well, rather than printing out a buttload of something that I don't know if it's going to be needed, I'll just do lots of testing and iterations.
Yeah, why not?
And tried heaps of different things, you know. And then even when I was printing the 200, I was trying to work out a way to stack them, and just, you know, I was doing them 2 at a time, stacking and going through and making sure they separated. And then once I got it right, then I printed the stack of 11, and then. You know, kind of by the time I'd done my 200, I'd worked out a stacking method.
Yeah, this like I can say, for our printing here in Sweden, with all the volunteers from Sweden printing, I've been advising against stacking from day one, because it takes quite some tuning to get that working.
Yeah, that's right.
Decent.
Yeah, it was a feat of trickery.
So a
especially
lot of the
to get them all so strong. Like, yeah, you can make them separate, no worries, but they're all going to be printed so cold that they break easily.
Yeah. No, so I did that print guide. I don't think if you've seen that on the website.
Probably. I don't read
Facebook.
print
Yeah,
guides.
but I did a very thorough print guide for like how to print.
Yeah, cool. Yeah.
To get them strong, and then I also advised against stacking because the results very varied.
That's right. Yeah.
And so in Sweden, I don't think about like really few people are stacking single extrusion because of how much I've been talking against it.
Yes, absolutely. Well, when I received this bundle to print, one of them was a single model and the other one was a pre-stacked model of 11 units. But the way that they're designed, it's beveled down, so the area that's stacking is like, you know, the middle of an hourglass, so it's very easy to separate. But it's still welded. Like I've got some here that these ones I can't get those apart without them. Wrong batch. But there's some that I can't get apart without breaking them. But this one, that's pretty easy. I can get them apart almost without a tool. But that was with my tweaks. But then the original one, you know, it just welded together. I was like, there's going to be a lot of people wasting a lot of plastic trying to do this, and I just did my best at making a video of how to, if you're going to print stacks, how to, you know, how to put a cooler layer in between them so that they're not fusing.
No, and I also had like lots of people like, can you do pre-stacked STLs? And I was like, no, I'm not going to do pre-stacked STLs. Because that's going to need adjusting for your printer, for your print settings, for your layer height.
Layer heights, exactly.
Because I know if I put a pre-stacked STL in the download, everyone with they just received their new printer. They're just going to put the largest stack they can find in there, printed for 28 hours, and they get a fused block there. And I didn't see that that's a good thing.
Great, man. Yeah, absolutely. Sometimes you waste more time trying to save it.
Yeah. So I've linked to like guides and also, you know, the software Luban.
Yes. Yeah.
Yeah. Louis, who is the developer of Luban, he introduced a stacking feature into Luban like 3 weeks ago or something like that. Just when people were starting to stack frames.
Yeah.
So and it's in the free download version of it. So you can just download Luban, just put the frame in there, press stack, set your spacing, and press enter, and set how many you want and press enter, and it makes ready-made stacks and everything.
Nice.
It even incorporates a feature that if you set a flag to 1, it even makes a small 1 millimeter rod through all the parts to join them as one STL, so Prusa Slicer doesn't get angry at the file.
Yeah. Oh, because it's something to do with the top and bottom layers and small Z gaps or something.
Yeah. If you don't have that joining part, it messes them up. It starts to print them without top and bottom layers, and or just fails to slice. Totally.
I found some very funny quirks in Cura with thin layer, like thin walls, and bits disappearing randomly, and not the whole layer disappearing, but only parts of a layer disappearing and things like that. Where the line width was just a slightly weird, you know, and I played around with getting the line width a certain width to fit nicely, so that you don't end up with infill somewhere or with that What's that thing with the thin wall? Ask the gods at Ultimaker what they're thinking with the thin wall activity doing the squiggle
Oh
thing.
yeah.
I always try and turn that off and then just make it so that I have a skinny enough inner wall to. It'd be awesome if you could have a number of inner walls and define different line widths for them as they went through the. That would be unreal.
Slicing algorithms are kind of black
I can
magic.
imagine.
I'm not getting into that part.
Yeah. It's
but it was
actually
quite fun. Like, can be like 4 years ago or something like that? When Cura had a super slow, the layer view rendering was so damn slow.
Yeah.
Actually, one of my coworkers at 3D-Works, and he rewrote the whole like the math part of it.
Really? Yeah, right.
So instead of using like Python to calculate everything, it was using a compiled number library from outside instead. And it sped up the layer view like 3 times or something like that.
Oh wow!
So that's actually what Cura is using today, still probably.
Yeah, cool.
And because he was just so annoyed that it was too slow and he was a
so
programmer
slow.
so
Yeah.
Well. Oh, I just realized that I have another project here I could show off. I almost forgot about this. I haven't been working on this since like probably last autumn. So this is the only cheap Chinese printer I own, for reference. It's a.
Oh, that looks almost like my little Suwei SW. That's cool.
It's a Creality Ender 2, I think, and I got on closeout for $99 or something like that.
Oh, I see what you've done with it, though. I see what you've done.
You see what I've done there?
I see what you've done. Awesome.
So this is a little paste extruder head on it. It's actually really compact. It's the same. It's actually not even the same weight as the original print head, so you don't lose any build area by using it.
That's awesome.
And the syringe is actually placed in exactly the same position as the original nozzle.
Yeah,
nice. Just a little bit further down, so you lose a little bit of Z height, but whatever.
So what? Yeah.
It's a fine threaded NEMA 11 motor from Robotech.
Yeah.
So this is actually really, really strong because it has a pitch. I think it has a lead of like 0.65 millimeters or something like that.
Right. So the torques, the
gearing is insane on it.
And precise.
Yeah, but this pushes down super hard, and it's like super compactly built.
Yeah, that's very, very nice bit of gear, man. I want one. How do you get one of them?
You ask me and I send you the files. I haven't been around publishing it yet.
Wow.
Because I haven't found the time to do that. But what I actually have been trying to do with this is printing these. This is a metal clay syringe.
I love you. That's what I was coming to.
Yeah.
Dude.
So these are the ones I've been printing with it.
Yeah, cool. I love precious metal clay. It's so cool.
Yeah.
I've wanted to bring that into 3D printing, but other than painting it on prints and then burning them out, I haven't really thought of a way to do it. So I have exactly what you've done, but I haven't. Yeah, that's cool. I'm flabbergasted.
No, so I just spent some time designing like this super compact print head for it, and basically the only mod I did to the printer and all is to just crimped the cable connections to the extruder stepper.
Yeah.
So
that's unreal. Dude, I'm very impressed, and I think you're cool regardless of your face shields.
Now we're getting some metal clays. That's okay.
Yes. You've brung the metal. That's cool.
So
now your results. Show me your results. What have you printed?
I actually don't have much here to show you. I was gonna see if I can get some pictures. I've had I managed to get it together, and then you started to print with it. Let's see if I can find the pictures from this. And I haven't really dialed in the extrusion really well and so on. Let's see, it should be like October probably? No, November probably.
Printing in precious metal clay, man, that's next level.
Yeah, then I have to find a kiln somewhere to burn it out and so on. But yeah,
blowtorch, dude. Blowtorch. Just get a blowtorch. Trust me, it's
okay.
Yeah, fine. Yeah, absolutely. I've done plenty of stuff just using blowtorch. Kiln's great because it gives you even heat and blah blah. But get yourself a few little fire bricks and make yourself a little corner somewhere that you can blast them in, and yeah, you'll be fine. Nice.
Yeah, like I said, I didn't had time to dial the extrusion in really well.
Tuning, no, bit of tuning. It's a weird stuff to work with at the best of times.
Yeah. But it's quite promising, to be honest.
Yeah.
And these are just done on
I reckon play with your wipe settings. I think might be one thing to play with. To make it wipe more, like a longer wipe might make the difference between it tearing the pieces, but also it's torn off.
Yeah, I've also been thinking about actually modifying the syringe holder to add a bit of extra support for the syringe going down.
So it's not flicky.
Because just right now it's flicking a little bit. So not a lot, but enough to make a difference there.
Have you thought about a cooling fan being modified into a heating fan? Like I've sort of thought, why not make a duct that blows warm air at things?
I haven't been thinking of that, to be honest, but could maybe work. Does precious metal clay does it get a lot easier to flow if you heat it?
No. I'm talking about blowing warm air on it to dry it as it comes out, so that you don't get the dew problem of printing with clay, like I've seen with regular clay printing, where the clay is kind of it starts to get a little bit wobbly and a bit how you're going. So I was trying to do some funny hand motions to look down. I'm not even on screen. So the clay prints tend to just have a bit of a organic floppy kind of look to them, which if you're printing metal parts, you could be using this for medical if you get that to print nice enough. Silver parts or there's a lot of potential for that.
Yeah, on the topic of printing weird stuff. This is another project of mine.
Bigger paste extruder?
No, not really. It's but yeah, could be or something
it's
like
a direct pellet extruder.
Yeah, no, it's actually a volume a dispenser pump. So it is it's called a Monnier pump or a progressive cavity pump, PCP. Which is it's a really cool type of pump if you haven't looked it up. It's an eccentric screw that wobbles in a silicone stator, which causes like every amount of rotation gives an exact volumetric amount pushed forward.
Okay.
Because it's like the screw doesn't act as a screw; it more acts as like an infinite amount of pistons that pushes it forward.
Okay, yeah.
So you get so every rotation gets an exact amount of volume out there. But this is actually a project I'm doing with the Royal Institute of Art in Sweden.
So what are you going to print with, silicon or?
No, this is going to print with wax.
Ah, cool. For the wax museum.
Yeah, more or less. No, but it's so that progressive cavity pump is actually custom built one from the German company Viscotech. It's way too expensive. Let's just say that. It's about the 10K mark. Just the extruder. And it's servo driven. It's a clear path servo there on top. And in the background there you can see a hose laying. That's a hydraulic hose with a heater cable inside to transport the melted wax.
Are you moving your mouse, or is your mouse in the same spot? I'm just wondering whether the screen's frozen or that's my mouse.
Yeah.
My mouse is sitting in the way, and I thought it was.
Oh, yeah.
No.
No, but here in the back, there's, I don't know, can you see my mouse?
Yep.
Yeah. So this is that's the heater, the heated hose. It's a
nice.
hydraulic hose with a heater cable inside. This is the heater jacket for the extruder, so the whole extruder is heated. And back here you can see a pressure pot with a Kinova heater wrapped around it.
Yeah, right. Yeah.
So it's we're actually melting the wax down back there with pressuring the pot, and then with about a few bars of air pressure, we're pushing the wax through the hose.
Just to get it there.
Yeah, just to get it out to the printhead. And then the whole printhead is heated and is volumetrically dispensing the wax.
Gotcha. Yep. So it's just being fed. That's what I pictured with a clay extruder, is having, like some kind of low pressure feeding it to the printhead, and then the printhead kind of grinds it out. So, that's
there is quite some resource source on clay printing if you want to look at that.
I've dabbled in the idea, and I've just it's one of those. I've put it on the back burner, knowing that I would love to do it, but it will. Then I do need a kiln for clay, and it's pipe dreams at the moment, but they do become reality.
So here's a Cerambot printhead for the Kickstarter ceramic printer. I've just received that a while ago, and it's basically this is a super simple extruder. It's basically a wooden screw.
Cool.
That is coupled to a NEMA 17 in the housing. So it basically goes down like this. Yeah, you have air pressure feeding the clay in here, and with low pressure, and then it's just a regular wood screw that's spinning and pushing it out. Brilliant. It's supposed to work decently. Well, I haven't tried it, but
yeah.
And so, to be honest, I don't know whether I'm gonna get time for this, but yeah.
Well, what you're doing with the precious metal clay, there's nothing stopping you from using regular ceramic clay in that same syringe as well. So
no. But the problem with that is that you get so small volumes from the syringe. So if it
depends on what you're making.
Yeah, if you want to do anything larger, then you need some.
Of course, that's right. Yeah. But no, for little jewelry and things, there's no reason not to use clay. The only reason you normally wouldn't is because you can't.
Yeah. No, but if we go back to the wax printer, the goal for that project is actually getting to print like large wax masters for casting.
Yes.
So cast in bronze or cast in glass.
Yeah.
So there's loads of art students that want me to finish that project.
Yeah.
But it's also one of these projects that I've joined in because it's a really interesting project, but they don't really have any project budget anymore.
Okay. Yeah.
So
artists, we're all the same.
So it's basically like all the time I put down into that is basically just voluntary work. That is also my work.
It's a cool project.
So so it's not going too fast at the moment. Well, especially now at the moment because the school is actually closed down because of the Corona crisis.
Yeah.
But it's a cool project. I'd really hope to get it done.
So the good thing about the wax is that you can melt it out at a low temperature and reclaim it and use it again.
Yeah. I can just
and then finish it off at the high temperature to finish cleaning it out, obviously. But
no, I can just take the and also like failed prints. I can just throw them back in the pressure pot and let them melt again.
Yeah.
Which is really useful for when prototyping.
Yeah, that's what interests me about a clay extruder as well. Is let's say you do use regular clay through an extruder like your precious metal clay extruder.
Mm-hmm.
The volume that you're going to use compared to how cheap the product is really good value for money.
Yeah.
So if you were printing normal 3D printing size things that people often print, stuff like, hand-sized, fist-sized, palm-sized objects, and you're treating it like you would PLA, then your clay's going to go a long way.
Oh yes, yeah, it's going to go forever.
But But firing the stuff at the end of the day is the thing. But I mean, if you get a paste extruder, you can extrude paper clay that doesn't necessarily need to be fired if you're not chucking it in water, you know, or the air dry clay or FEMA or all that different types of polymer clays. You know, they're very cheap, and you cook them in the oven at home. You know.
Yeah, definitely.
Then again, polymer clay is probably not cheap compared to PLA. So
no, but it's still cheap compared to precious metal clay.
Yes, that's very true, and you can test your designs. And now here's the thing: I played with paper clay and repaired a precious metal clay thing that broke, and then put precious metal clay back over the top and cooked it, and it worked. So paper clay was fairly compatible with the precious metal clay, even though I was working it in the most insane wrong way that you possibly could with thermal expansion and stuff. So keep that in mind. Yeah, I'll quickly grab the thing I made.
Yep. Let's see.
You guys talking or waiting for me?
No, waiting for you.
Yeah, so that's a raven skull, and there's actually a cremated raven skull inside that. So when I originally did it, the beak was open, and in a cooking accident, or more to the point, a drying accident, it fell off and broke into lots of pieces. So I had to put it back together. So yeah, so there's an actual skull in there, and I've brushed on the precious metal clay and did multiple coats. And then when I started to fire it, the beak started to expand and mushroom like popcorn. And so I had to go, oh man, what am I going to do? Like, I'm so invested in this. I've put like about $100 worth of precious metal clay on this skull, and eventually realized that if I did it really slow, if I cook it really slowly, all that keratin would kind of, you know, do its thing slowly and degas and not expand. So I was doing that on the stove at home on a colander or something like that, and then, you know, the ping factor when metal expands and contracts. I think my missus came home and said, "Oh, that stinks. Turn it off." So I turned it off, and as it cooled, it went ping, and like smash. So yeah, that happened, and then I pieced it back together and used paper clay to join all the bits in, and then just painted precious metal clay over the top and fired it with the blowtorch, and it worked. So
it seems like you have way more experience in precious metal clays than I do. I just
playing with it though, like not printing with it.
I just thought they were cool and wanted to see if I could print with them.
Yeah, I think that you're onto something, man. Like the jewelry potential is amazing. The medical potential is amazing.
You know, I said I'm working in 3D printing, so we're except Ultimaker. Then we're also the distributor for Formlabs. So I've been doing quite some SLA printing with really high details for jewelry. Cool. I have a cool coworker who designed a really nice signet ring, and in their castable material, and burnt it out and cast silver in it. So he's got a super cool signet ring.
Yeah, cool.
And we're also working with Mark Forged. So
yeah, right, yeah.
So this knife handle is actually Kevlar reinforced.
Oh wow!
Not that it needs to be, but it's cool.
Yeah, why not?
And we're exactly. And we're also working with the Metal X system, which is basically like precious metal clay but with steel and
no, that's embedded. That's embedded in plastic. It is in filament form.
Yeah.
Do they preheat that before it goes along the system?
No, you actually wash it. So what it's a the binder in it is actually 1 part polymer and 1 part wax.
Oh, this is after you print. Yeah. No, I was talking about before you print with it. The filament itself.
Yeah. You
warm that so it doesn't.
Yeah. Yeah, the whole print chamber is heated to like.
Yeah, because otherwise it's brittle and.
Yeah, it's super brittle at room temperature.
Yeah,
like
I printed with conductive filament,
like
and it's
if you
so
take
hard.
if you take a piece of filament like this and just drop it on your desk from like 40 centimeters high, yeah, it shatters into like 10 pieces.
Yeah,
It's super brittle.
Yeah.
So you need to have it in the heated chamber for like 5 minutes or 10 minutes before you actually even feed it
get it
into the
soft.
extruder. Yeah.
Yeah.
And then it's actually pretty ductile and nice when it's hot.
I tried to do that with a fan heater and some like lights and stuff to try and just heat it as it came off the roll so that it would at least be warm when it straightened out. But that wasn't proper metal stuff. That was just conductive.
Yeah. No, and there's so many weird materials I've been doing stuff with. You probably also know that I'm my actual work is I do some product development at 3D Verkstan, and probably the most known product is this one.
Oh, really? Wow.
Yeah,
Yes.
so I'm the lead engineer for Olsen Ruby, our product line.
That's funny. That's cool.
Yeah. That's probably the other thing.
I kind of troll people when I see them with one because it's like, that's so expensive. You could buy so many cheap nozzles for that. But that's cool. That's awesome to meet you anyway.
and I can say that for a lot of usage, it is totally overkill. I can say this though my job actually quite kind of depends on it. No, but like people printing a regular PLA with a Ruby nozzle, that's insane.
Yeah.
If you ask Nyotko on Twitter, he will say it's not insane because he gets like
good results.
He gets insane quality.
Yeah.
Ruby nozzles, but for the 99 other percent, I would say that it's totally overkill. You know what the Ruby nozzles actually were developed for in the beginning?
Carbon and stuff like that, or
no? Carbon fiber filaments wasn't a thing when we developed rules of Ruby.
Oh, okay.
They came right when we released also Ruby. Carbon fiber filaments started getting popular, so it was a very good timing thing.
Yeah, for sure.
But it wasn't developed for that at all. The original thing was that Anders Olsson, who's given the name to the product, he were at the time. He was a research engineer at Uppsala University on the physics institution, and they were doing experiments with 3D printing neutron absorbent filaments for nuclear physics experiments.
So
like sample holders you put in front of a particle accelerator to shoot neutrons and stuff, and you need to block neutrons from not coming out the wrong way.
So what was in the filament?
Boron carbide. And boron carbide is the same thing as if you look at on the super high-end industrial grinding wheels. They're made out of boron carbide. That's the more expensive ones. Those, not the aluminum oxide ones. Those are simple. But the super hard boron carbide ones. Boron carbide is like the third hardest material you can find.
Yeah,
you get diamond. You get cubic boron nitride, and then it's boron carbide. So if
that was impregnated in plastic, or obviously because it's being printed through an FDM printer.
Like 70%, I think, was the most they printed with.
Yeah, okay.
But the most are printed with like 50%.
And that's just to give it a good abrasion resistance. Is that right?
Let's say that the abrasiveness of that material is so high that I think that regular brass nozzles were basically worn out in 50 grams.
Yeah. So it's abrasion resistant in printed form, but it's abrasive as a printable product.
Yeah, but
the end product would be abrasion resistant.
Yeah, it would be, but that's not the thing they're looking for. The thing they're looking for is the boron content of the boron part of the boron carbide. The boron is extremely good as a neutron absorbent.
Okay, so it's a doping thing. They're doping the plastic with it for that reason, nothing to do with its physical strength or
nothing with the physical at all. No, it's basically if they could choose, they would print 100% boron carbide.
Yes, I see.
But they can't, so they need some binder in there.
Yeah.
And they did And the thing is that the alternatives for doing that is really limited, because if there is boron carbide plastic sheets to buy for like these nuclear facilities, those can only be cut with water jets. Because since you have the third hardest material in the plastic, if you try to push a milling cutter in there, it's going to be ruined in 1 second. If you try to drill it, it's ruined. If you try to saw it, it's ruined. Like any kind of mechanical working, you just ruin the tools instantly. So water jet was the only option, which means you're limited to 2D shapes and so on. And if you needed to like make something that could be more formed, the only option were cadmium.
Yeah.
So you can work with cadmium sheet metal and fold it and so on. And working with the super toxic heavy metal and milling that, let's just say it's not something you want to do if you can avoid it, like in any way. So even if it was extremely harsh on the printers and extremely expensive and so on, it was actually still a really good solution. And actually, just I think 2 months ago or something like that, a Swedish company, not related to us in any way, but a Swedish company actually launched a commercial filament based on that technology now.
Yeah, right.
It's super expensive, like super expensive. I think 1 kilo is like probably like $1,000, something like that.
Far out. I thought that graphene filled stuff was expensive.
Oh yeah, they have a graphene fill too. So, but this one is even more expensive. No, because it wears down extrusion lines as well. It ruins the filament extruders because it's so abrasive. So they actually have to factor in buying new extrusion screws and new extrusion barrels.
Gigantic ruby nozzle this big on the front of the extrusion line.
But you know what? Actually, that filament wears down ruby nozzles.
Yeah, right. Okay.
Yeah, because it's harder than ruby.
Yes. Okay.
But it still lasts a few days of printing.
Yeah, that's all that matters, I suppose. At the end of the day.
Well,
as long as it gets the job done.
It enables you to actually get the prints out.
Yep.
And one of the reasons they weren't going for, why they weren't even trying with hardened steel nozzles in the beginning, is that a lot of steels has a tiny % of cobalt in them.
Oh, and that's bad in the end.
And if you have cobalt in the end product and you irradiate that with neutrons, it gets insanely radioactive. And then you have to store that in this very complicated and expensive waste for a long time, which is a really bad thing. And also that's the reason why it's not tungsten carbide, because that's also like 20% cobalt.
Yeah.
But
so you're putting an abrasive material through a product that you don't want getting in your end result.
Yep. Exactly.
If you get a bit of ruby in there, it doesn't matter because it's not
it's
volatile to the situation.
Yeah.
That's inert.
Yeah, ruby. It's just pure monocrystalline aluminum oxide.
Yeah.
No. So that was actually the main reason for why that product turned out as it were. Then
it's completely justifiable, absolutely 100%.
Yeah, and then the demand for abrasive elements of other kinds turned up about the same time.
Yeah.
I actually recognized them, like back in 2016. I was sitting with my boss and we were discussing like, are we really going to launch this product commercially? It's going to cost a lot. It's going to take some time. Are we going to sell more than like 200 pieces, something like that? We didn't know.
Yeah, no, they seem like they've taken off well enough for you.
We sold like plus 20,000 pieces, so it's probably okay.
Yeah, for sure.
And we're also working with multiple like OEMs and so on. But
is it possible to machine like more of the hot end? More of the nozzle itself out of the ruby, or was that hard enough as it was to?
It is possible.
Is there a disadvantage there?
It's not really feasible because it doesn't add much
value at all. Yeah.
No. you could even argue that it gets worse because the thermal conductivity of the ruby is so
Not as
much
good.
worse than it is of the brass or the copper.
Yeah.
So this one is actually the our high temp version.
Okay.
This is a zirconia doped copper with a chromium nitride surface coating. That one can actually take 500 degrees with no problem. Print carbon fiber filled peak and so on.
So was that an issue with the regular ones? At some temperature, they start to lose
if you have like brass loses most of its rigidity at about 350. And at 500, brass is basically super soft, so it can't.
Basically like lead at room temperature.
Yeah, so you can't really use brass at temperatures over 350.
I use either hardened steel or stainless steel for most of my printing, and that does me fine. And
it's actually quite interesting because hardened steel, you can't use hardened steel at 500.
Right.
Because at those temperatures you are annealing the hardened steel, so it's not hardened anymore.
Yep, there you go. There you go.
Not instant. I'll be right back in 5 minutes max. Okay. Just so you guys
don't fall asleep. Don't fall asleep.
No, I won't fall asleep. Believe me, I'm doing something to stay awake.
Oh yeah.
Cool. Man, I'm sort of starstruck. Like it's honestly, I didn't really know who you were when I saw the masks. And then piecing all the bits and pieces together, you're a cool dude, man. It's really cool to meet you.
I'm probably not that good at showing off what I'm actually doing. I'm not the best guy on social media.
You're not a show off.
I can show some other things I'm doing too. Let's see.
Oh, he's got a little kit with lots of little things in there.
Oh yeah, I got lots of kits with small things in there. No, but this is also a product I developed and we're selling 3D-Works on. This is custom tips for Valor soldering irons for putting in heat inserts.
Ah, nice. So you screw the insert onto it and then poke it in and unscrew it, or
you just push it on like that. Slips on.
Cool.
But just a really tight fit.
Yeah,
and
cool.
You just heat them, push it into the plastic, insert inserts.
Happy days.
And since this got the machined face here, it's super flat. It's really easy to get it straight into the plastic, which is quite hard if you use a regular soldering iron.
Because the tip wants to flop from side to side, because it's on a conical shaped thing.
Yeah, exactly, and it usually flips all the way to one side, and then you have to try to compensate with your iron in an angle,
and that zigzags it into the hole and messy. Yeah, cool.
Yeah.
Cool.
So I'm actually working on bringing out this whole kit to market.
Nice.
This
would be awesome would be somehow if you could make it so it had a stopper so that it didn't go in too far. Something that.
Yeah, I've been working on that and trying to force this flat also, but
it's hard because you don't want the tool to be bulky.
Nope.
And you don't want it's an awkward thing to try and manufacture.
And you don't want it to be hot because you don't want to melt the surface, but you don't want to affix it a long way distance from the from the tip, because then it gets it's a lot of different.
What about sort of like a guide that you line up and put on the part first, and then you sort of stab your thing into it and it goes ka-chunk?
Yep.
Something like that. But again, you've got to be able to get the tool on the job, and for most you're often doing them in awkward. Like you try doing that on a hot end, like a fan shroud or something that's got little inserted nuts all over from every which way, or the weird angles we like to twist.
And often you set one of the screws really close to a corner, especially internal corners, which also makes it really hard to get.
You get no chance of getting a guide in there at all whatsoever.
No, exactly. And just because of that, I'm gonna bring out another project here.
I wonder if you make a tip for that's got a slight bend to it, similar to the one you've got, but that just goes out and bends at 45 degrees for getting into corners.
Currently not, but we have been looking into it.
That will get you out of some trouble. Oh, cool.
So, I don't know if you know this one. It's the Project FDL Nerf gun.
Yes, yep, yep. I am actually familiar with that. Yeah, that's cool. I haven't seen that version, or at least I haven't seen it in black, and it looks bloody awesome.
No, they don't recommend you doing it in black because Nerf shouldn't be black and so on.
Yeah, okay. Yeah.
But we don't have that rule in Sweden, and it looks nice.
Yeah.
But this one is actually this one is actually my version. That is, I actually went into the files and every like 60% or 80% of the screws are in heat inserts.
Yeah,
so
cool.
the shredded inserts all through this thing, and it's all printed in carbon fiber filaments of different kinds.
Oh man, very nice.
So yeah,
That's cool.
It's more or less all carbon fiber. Except some of the parts back here is actually PLA because they're still the prototype ones.
Yeah, yeah.
But I actually managed to get a snap lock working in PLA that works
cool.
super reliably. So you can just fold the stock away like that.
Nice.
And then it snaps like that, and it works.
That's
really,
good.
really well.
And that looks like it's all snug. It doesn't look like there's any wobble in it.
No, it's really good actually. Super solid. And it's like got a TPU butt plate here, and
cool.
Yeah, this and also I got a custom designed muzzle for it that I draw up, which prints supportless also because of the angles and so on.
What CAD software do you work with?
Fusion 360.
Yep, cool.
Yeah. Now this happened about after last Murph because I got to test fire some of the FDLs at Murph.
Yeah.
And they were way too fun.
And
a few weeks after, some of my colleagues started bringing Nerf guns to the office. So
bring that.
I actually, I was at Earth, and one of the they had the guns there, right?
Yeah.
So I went up to one of my friends. He was like, "Yeah," he's like, "Yeah, you can shoot me." I grabbed the gun before he could change his mind. I was like, on a scale from 1 to 10, how much, did that hurt? He's like, "Ow." Those things, I'm saving up my pennies and everything else. That's gonna be the first thing I'm gonna get myself.
You saw that they actually just started pre-orders for the new electronics kits that they doing with LDO.
Yep.
Oh, that's cool. Because what happened there? I remember watching someone interview them, and they sort of stopped doing the kits or something. Or suppliers getting good quality, same parts over and over again, or something like that.
Yeah, and they basically went from when they open sourced the FDL3, they went from being a custom Nerf shop that was doing custom Nerfs for people, or dart launchers. Sorry, no brand name here. But they went from being a custom shop to like being a parts supplier for people that like 3D printing.
Yep.
Which meant
big
that they're
shift.
Yeah, and all the supply issues caught up on them. Like they're a really nice couple.
They're awesome.
Yeah, they're awesome.
They're the kindest, sweetest couple you could ever meet.
Yeah, that's what I could see from the interview I watched. It looked like a really legit.
Yeah, they are.
I'm gonna bring in two people. I'm gonna bring back in JT, who was lucky enough to actually eat dinner. And Karl from Knack 3D Designs. Did you ever hear of White Knight?
Oh yeah. I talked to Karl a few times. He's back now.
Yeah.
He was on about the time when I went to sleep.
I missed the start of the stream because I was sleeping.
All right. So we got JT and Karl. And guys, I need to take the headphones off between the headphones.
Oh yeah, you should do so.
I need something for the ears.
Karl, I just want to say now, I love your work, man. I think you've done a really good job with that White Knight.
Can you hear me?
Yep.
Yes, we can hear you now. Wait, hold on. I have a very important question. Karl, can you see everyone?
Do you get the gallery view working?
I can't hear a thing.
Get out.
He's teasing. That means it's his end.
Yeah.
I need something.
Karl, I just want to say now,
We
I love your work,
can
man.
hear
I think
you.
You've done a really good job with that white knight.
Can you hear me?
Yes, we can hear you now. Wait.
Well, I'm getting some feedback.
Yeah,
Yeah,
he's
I
playing the video.
Ah, that's okay.
If I mute the YouTube stream, I can't hear any of the audio for some reason now, though.
Did you download? Hold on.
That means
Karl, switch over.
Yeah, it's on my end somewhere. Yeah.
Hold on.
But you guys have seen this one firing?
Oh yeah, I'll see that. Go, shoot.
Why can't I hear?
1 second.
Yeah, hold
My
on.
goodness.
I'll mute it again and figure out what's going on.
That was 22 darts. Fire
Zoom
rate
does
of
not like me.
16 darts per second, I think.
That is insane, Erik. That's insane.
They're way too fun. But it also turned down my colleagues' will to play Nerf Wars at the office.
I can hear you now.
Yeah, I bet.
Oh, you can hear us now. Awesome.
So, Karl, pop out the chat from the YouTube and then close the YouTube.
I've got it muted now, so it shouldn't be a problem anymore.
Cool.
Okay.
The only reason I turned it on for that brief moment was because I couldn't hear what was going on. Yeah,
Cool.
Erik knows all about the White Knight. He actually made the nozzles I'm using right now. So,
Oh, you're using them. Nice.
they're definitely better than the ones I was trying to turn on my lathe.
Oh, yeah, I can imagine. No, I've actually made a custom set of nozzles for Karl, designed them, and made some prototypes. Haven't gone any further with it though, since
Yeah,
there's not been a lot of requests for them.
that kind of died off. I don't think, from what I'm hearing, it doesn't sound like the kits are ever going to happen. At least not by printing solid.
No,
Bummer.
that happens. No, I still think it's a super cool project. So
And I got another one on the way, though. I don't know if it won't need custom cut nozzles for it, but.
you're not gonna do as much of an angle.
I'm not going to do any angle. I'm actually working on one right now with Chris Warcocky. I'm going to build what we're calling the belt bear. It's going to be
so basically the MakerBot automated build plate in
pretty much
2020. Yeah,
very, very similar to it. Yeah, and once again, something that won't be sold by anybody because it's way too close to a patent. But
oh yeah,
I'm gonna keep doing what I do. It's like I'm gonna do the research, I'm gonna make it work, and then I'm gonna post on my research. If someone wants to make them, that's up to them.
Open source by force, mate. Do it.
Yeah. If it all goes as planned, you should be able to take the top portion of an MK3 Prusa Bear kit and lift off the X and Z axis, and the belt's going to be the Y axis. You'll just bolt it all right down to the belt system I'm designing and go right back to printing.
Nice.
you should have made it already. It would have been super nice to have now the last few weeks.
Yeah,
Yeah.
you should have made this sooner. I'm like, well, I can't rush it. Unfortunately, belts are a 6-week lead time, and I'm waiting a month just to get the extrusion. So.
Yeah, I know about lead times. I like a while ago I showed off a custom wax printer that I'm building, and the printer on that one had 18 weeks lead time.
Oh wow.
And was delayed, so I think it took 22 weeks from order until we got it. And that was with a 15K price tag. So yeah.
The joys of eBay.
Oh, yes.
Not eBay, but
Custom German engineering takes time.
Yep.
Yes, but
Don't
it usually
rush
goes
quality.
so fast.
Yeah. No, but it would have been really nice to have some automated belt printing last few weeks.
Yeah, I had a few people ask me why I wasn't pumping out the masks like Black Belt showed that one video. I'm like, yeah, but Black Belt didn't show anybody grab the 2 arms on that and pull at all.
Oh, no. I'm actually a little bit annoyed on how they did that. I didn't write to them though. I've actually been to Black Bolt and met the guys behind Black Bolt, and they are super cool, by the way. The story about how Black Belt actually happened is really fun, because the lead engineer at Black Belt is called, I think his name is Stefan, but I'm not 100% on that. He was an intern at ColorFab for his degree, and he was just working on like filament testing or something like that. And they had a guy coming in from Philips that asked him if he could print like a full-size light armature. And it was like, no, we don't have a printer large enough to do that. Yeah, like a fluorescent light